Okay, hi everyone. If you remember, what we ended class with was this general antiderivative of x to the n, and then that equals 1 over n plus 1, x to the n plus 1 plus c. And that worked for all n except for n equals -1. Now, this is really great if we have polynomials. We can now find the antiderivative of them. But what if we don't have x to some power? What if we actually have some trig functions? So in order to look at that, I wanted to recall something else. And that would be what the derivatives are for all the trig functions. So if you want, while we're going through this, you could quiz yourself and see if you remember them all. And then we usually do cosecant x here, secant x, cotangent x. Alright, the derivative of sine was the nice one. It was cosine x. The derivative of cosine is negative sine x. Tangent, the derivative was secant squared x. We got cosecant is negative cosecant x, cotangent x. Secant was secant x, tangent x. And then cotangent was negative cosecant squared x. Alright, now to actually look at the antiderivatives, let's look at this next thing. If we wanted to look at the antiderivative of sine x dx, then when we go to find the antiderivative, we know that it involves sine, but, well, the antiderivative involves cosine, but we're going to have a negative in there. So our answer is negative cosine x plus c. And we can double check that by taking the derivative of our answer, our antiderivative, and then seeing if we get sine x. So let's take the derivative one at a time here. So the negatives along for the ride. The derivative of cosine is negative sine x. And then the derivative of c is 0. Okay, then we got a negative and a negative, and we get sine x. And so therefore, this is correct. Okay, the next one is even easier or more exciting. If we go to find the integral of cosine x dx, when we go to integrate that, that just is sine x plus c. Again, we can double check that by taking the derivatives. So we got sine x plus c. That derivative, the derivative of sine is cosine x, and then the derivative of c is 0. So we get that it's just cosine x, and that's what was in our integral. And so we have integrated that correctly. And this is, so if you want to memorize these two things that I boxed, you can. Or what I always do is just double check if I'm right by taking the derivative. Either way you want to do it is completely fine. Now the other thing that I wanted to mention was, actually, while I'm highlighting things, I wanted to highlight that if we have cosine, the integral is sine. If we have sine, the integral of sine, it is negative cosine. So we have to correct for that negative sign. Then we would know what the integral of secant squared is. That equals tangent x plus c. Similarly, if we wanted to look at the integral of cosecant x, cotangent x dx, then that is going to equal, we got to correct for that negative sign. It's going to be negative cosecant x plus c. Moving on, if we integrate secant, I wish I just had a little bit more room here. Secant x tangent x dx, that's going to give us secant x plus c. And finally, we got just cosecant squared x dx. To correct for that negative sign, we got negative cotangent x plus c. Now you could actually take the derivatives of our solution, our antiderivatives here. So we could actually take the derivative of tangent x. Well, that looks terrible. Tangent x, and then we get secant x, which is exactly what we wanted. The derivative of cosecant x is negative cosecant cotangent, and then we have another times the negative, and so on and so forth. So you can double check everything. However, the last thing that I wanted to point out is that if we wanted to, see how we started out with the highlighted yellow portions, the antiderivative of sine and the antiderivative of cosine. And for right now, you might think that we would move on to the integral of tangent x dx, but it turns out that this is more complicated. None of our derivatives that we've ever taken has given you just tangent x. So that's why we don't know what the antiderivative is. And actually, you will see what this is in Calc 2. Okay, so that's just something to keep in mind. All right, and I guess that's all I wanted to mention here for antiderivatives with trig